Almost every day, people use the word measure incorrectly. You see, measure this donut for me, measure the duster for me, measure the phone for me. But actually, you can't measure a matter. You can only measure the quantity of matter. For example, after measuring this donut, you can say the volume of the donut is, just give it anything. Let's say the volume is 10 cm cube. You can say the height of the donut is, let's say, 5 centimeter, and so on like that. So all these things you are measuring are quantities of matter, and they by themselves are not matter. So you cannot measure matter, you can only measure a quantity of matter. You can measure volume, you can measure weight, you can measure height, you can measure area, and many other things like that. So is it possible for us to measure all kind of quantity? For example, let's say this is Tade. Tade is a runner, and let's say you want to run through this part. Let's call the length of this part D. Now, what we intend to measure about Tade is the speed. There is no way we can measure the speed of Tade without having to measure the distance Tade will cover or Tade covers, and also measuring the time it took Tade to cover that distance. So let's say the distance here is D and the time is T. So we can say the speed of Tade depends on the distance he covers and the time it took him to cover the distance. The formula for speed is distance over time. So on this basis, those things we cannot measure but that we can only derive from some things that can be measured are called derived quantity. So the quantity can either be measured on its own, and depending on nothing, that makes it fundamental, and it can also depend on fundamental or some other derived quantity that make it derived. Let's call this F, let's call this D, capital letter D for now. Now, the meaning of what I'm saying is, if you have a fundamental quantity, you have to measure it, unless in some cases you should not mistake this to being derived. For example, let's say someone already knows Tade's speed, and let's say Tade's speed is 5 meters per second. So because someone already knows Tade's speed, and this is the part Tade is running through, this part is 10 meters. It is possible for you to calculate the time it will take Tade to run through this part. But in the initial stage, before knowing what Tade's speed was, you have to measure Tade's time directly, probably using a stopwatch, and measure the part. That is when you get this. So the fact that you can calculate some fundamental quantity from derived quantity does not make them derived, but they are still fundamental. Just that when you calculate derived quantity from fundamental quantity, you can also calculate fundamental quantity from derived quantity. It's just like you are doing a back calculation. So that's one thing to note. So a few of fundamental quantities are your length, time, mass, electric current, temperature, amount, and so on. And you also have derived quantity that are derived from fundamental quantities. For example, if you look at area is the product of length and breadth. If you look at your volume, it's the product of length, breadth, and height. If you look at density, it is mass over volume. Speed is derived from distance and time. Velocity is derived from displacement and time. Acceleration is derived from velocity and time. And if you look at velocity, it is a derived quantity. So it is possible you derived a derived quantity from another derived quantity. And if you look at force, it is mass times acceleration. And acceleration is also a derived quantity. So practice these questions, and thanks for watching.